This is going to be tough after the awesome talk that Ms. Ra gave, but I'll do my best. I'm also going to be talking about HashiCorp stuff, but in a very different context. And I'm going to be talking of how we use Terraform in source to provision Baremetal through a few cool projects that CoreOS have and a few providers that you can use with Terraform. So seriously, are you using Baremetal? Now we're 2018. For us, it makes a lot of sense. What do we do at Source? Source, we do machine learning on source code. And that means that we download Git repositories at scale, meaning we aim to download everything that's public in GitHub, everything that's public in Bitbucket, and store it and be able to query it in a SQL-like fashion, in a distributed SQL-like fashion, and over that, we create the models that we train using machine learning. So for us, the difference of going into a cloud provider, we were using Google, and going Baremetal is a fifth. We were paying something like 100K per month, and we reduced it to 20K. So for that, it makes a lot of sense. When you go Baremetal, you get very, very good servers. You get servers with lots of RAM and good CPUs and a very good price, so it makes sense. And vendor lock-in, as you know, is a thing, especially when you're working in AWS and you have everything you need, everything you want, and you start doing all the amazing services that they offer. It's like it's a candy. So when you go Baremetal, at least you are sure that you are free to move, but you have things. Really, Baremetal scaling is tougher, not only because you cannot just request through an API a server, it's because sometimes the servers that you want are not available, for example, or they're not available in the data center that you want. So you have to plan things in advance and make sure that you don't get caught by a certain model of hardware, or you can mix and match whatever you need. It's less flexible. You need a higher investment at the beginning, and you are going to be dealing with technologies that we haven't touched for a while. And which technologies are that? You definitely need DHCP to assign IPs to your servers and to tell them where are the images that they need to boot. You need all these PXE, iPXE execution environment in order to deliver all that. You need TFTP. Yes, PXE delivers the images through TFTP, so you need that. And you need all the assets delivery, things like the initrds, the kernels, and the configurations. So all that you get for granted when you are in Amazon or when you're in Google, you have to do it for yourself. And one thing that is very important is that you need some kind of flexibility. Normally, at least imagine our case, that we are going to be deploying a Kubernetes cluster. At least you need a couple of different roles. You need masters, you need workers. So you need some kind of role-based execution environment. Things like which image, which configuration you need to deliver. And the cool thing is that CoreOS loves Baremetal, and they give you very, very cool tools to do all that we need. So what are we going to use for that DHCP, TFTP, PXE part? We're going to use DNS mask and they provide a DNS mask loaded with all the goodies that we need, especially the images to chain load from Pixie to iPixie. I will talk about that later. What else were we talking about? You need something like a role-based configuration and role-based kernel images delivery. They have a project for that that's called Matchbox, that it is an iPixie server and an assets delivery and Ignition delivery server. What's Ignition? Ignition I'm going to talk about later, but the thing is that it helps you to configure the servers the way you want. Things like partitioning, things like which system units are you going to be running. So let's refresh a bit some concepts about how a server boots in the Pixie iPixie world. There are more requests that are there, but this is the main thing. The idea is that when this appeared, this was in the late 90s, the Pixie implementers, they used the FTP as the way to give the initrd and the kernel images to the servers that they need. The complicated thing is that you don't have all that you want when you are going TFTP. You cannot say, hey, I have this characteristic, I have this MAC, I have this whatever, and I want a specific kernel image. I want a specific configuration for my server. So what we do is that normally all your network cards support Pixie, and the way of working is to chain load to iPixie. So the first part is, hey, DHCP, give me an IP, give me an image to boot, and this image that we serve at the beginning is an image that is capable of doing iPixie, and then we continue. Then again, iPixie goes the DHCP to know where to boot, and then it gets the initrd images and the kernel images via HTTP. The good thing is that it can say, for example, in the URL, hey, I have this MAC. So with this MAC, as a selector, you can choose whatever you want or where to boot your server. So enter Matchbox. Matchbox is the first part that it is very interesting to work with Baremetal. Basically, it gives us all that we were speaking about. It gives you the possibility of selecting which kernel are you going to serve and which configuration are you going to serve. So the first thing, it defines groups, which can be groups of one server or multiple servers, depending on what you use as a selector. For example, this is an image that I've stolen from the guys of CoreOS. You have a few servers. Each of them have a certain selector. For example, in this case, based on MAC. And we define groups that basically are going to give you a profile. A profile defines which kernel to boot and which configuration to boot, which configuration to use. And that configuration is given through Ignition. More on that later. So let's recap. Groups define selector which match 0 or more machines. Profiles define a config and some network boot settings. Ignition, we'll see, it's the way of configuring CoreOS, and assets are these kernel images. Basically, it is an HTTP server that serves assets. And the cool thing is that you can either write all those files that you need, or you can use a gRPC endpoint to send information. And that's exactly what we're going to be using when we do it via Terraform. So this is what a Matchbox group looks like. It has an ID. It defines a profile. It defines a selector. This group applies to servers that have this MAC, in this case, a server. But there are selectors based on domain, for example, that could match more than one server. And it defines this metadata. This metadata can be used in the Ignition config in order to be able to reuse it across different groups. For example, you can define, you can use the same exact Ignition template for multiple groups because you are going to define some kind of metadata. The Matchbox profiles defines as we said, that those network configuration basically defines where to get the init RD and the kernel files, and it defines where some boot arguments, which the most interesting in this case is where to get the configuration, the Ignition file. The assets are loaded manually. There's a nice script provided by CoreOS that allows you to download a certain version of CoreOS and put it in the place where Matchbox expects it. And Ignition, which is a very interesting project. The first thing is that Ignition is not only used in this context. Ignition can be used in more contexts because what it does, it is manipulate disk during this init-ramfs phase of the Linux boot process. And because it runs so early, it allows you to do a lot of very, very fancy stuff. If you can copy whatever file that you want, you can configure all your network D units, you can configure all your system D units, you can do things like partitioning, like formatting disk, all that before your system starts, your init, all before init. So as I said, you can, for example, if you're installing CoreOS in AWS, you can use an Ignition file. You put it as user data, for example, and it gets it, and it applies everything it needs in that scenario. Or you can use it manually by booting from a USB stick and then using it in the CoreOS installer. The idea is that the way that Ignition works, it is through JSON files. Whenever a server wants, hey, give me my Ignition file, it receives a JSON file. Writing JSON manually, it's one of the worst ideas that you can have, or using JSON as a configuration file. It's a pretty bad idea because it doesn't support things like comments. So it is not handy to use it manually. So normally what we do is to write YAML files that are much more easy to work with, and they get transpiled to JSON. And as I said before, you can, through those groups, metadata, you can introduce variables that are expanded. What we can use in Matchbox are YAML templates. So this is how it looks like. Normally, when you are doing it manually, you start creating quite long YAML files that have all what you need. You have a network D, as in the example. You have a network D part. You have a system D section. You have a file section that you can copy files, or you can manipulate disks, or you can add users. And these get transpiled to JSON ignition files that they look as you can see. The problem with this, the problem that we started to have, is that when you have a few roles that are similar, for example, in our case, the most basic thing was to have a master and workers. There were many of these sections that were pretty similar. So you ended up by having a few templates that are very similar, and but you can that are completely separated. So the first thing we started thinking about different approaches for this. Hey, you can maybe have a way to build them using some kind of templating, or you define pieces of work and then pieces of YAML, and then you start writing a pseudo YAML that you parse, for example, using includes. We didn't find anything that was satisfying for us, because what we wanted is something that was like I'm saying, something high level that it can be reusable. So at the end, what we developed at Sourced is, hey, we are using, at the end, we can use Terraform for this. Why don't we generate those JSON files using Terraform? And you can say, hey, but you're not creating resources, but in Terraform you have logical providers that basically what they do is to create the configuration that you can use, and then that are going to be used by a third system. So this is exactly what we did. So the first thing is, instead of writing those YAML files, we are going to do something very similar, but that can be reusable. And how do you reuse things in Terraform? You can create modules. You can, for example, create those, if all your networking is the same, you can create a module that renders the networking part as you want it. And in order to use Terraform with this, we need, or we use another provider that is the one that is talking with the Matchbox server through this gRPC endpoint. As I said, these are logical providers. They don't create resources for you. You don't have like a DNS address or a static IP or an instance. What you have is configuration that is going to be used. And let's have a demo and see how this looks like. Everything from this demo is there. So if I go very fast at some point, it's there. What this demo is about is creating an etcd cluster, and in order for it to be reusable and for people to play, I'm using VirtualBox in order to spawn all the servers that we need, instead of doing something fancy like, or more Baremetal-ish, like what could be a Raspberry Pi or something like that. So, do you see anything, or should I make it big? It's okay? Okay, so this is that repository. Basically, what I have here is a vagrant file that what it does is it creates all the parts that I need and creates an internal network. This first server, which is the one that it is the provisioner, what it has running is a couple of Docker containers, one with DNS mask and one with Matchbox. It has two interfaces, one internal, which is this one, which is the one that is going to be used to provision all the things that we need, and your typical interface, that's nothing. So if we take a look to how this looks like, the Terraform, we have this environment, this main. Every server that we are going to be booting, is going to use this master module that is going to create, or that contains all the information on how to create all the things that we've said, basically those groups, those profiles, those ignition files. And the only things that we are going to be giving are those three variables: the host name, the MAC that is going to be used by the Matchbox Pixie part to choose to choose how to configure the different servers, and this etcd initial cluster is going to be used by the etcd to define how that cluster is booted. So if we take a quick look to Terraform modules, that's the first thing that we see is that provider that you always need to declare, that needs an endpoint, which is basically local host, and that those client certificate in order to communicate. We defined a resource group, a Matchbox group, that every server is going to be different, because every server is going to have that selector different, which is the MAC. And then we're going to define that profile associated with that group that defines which images we are going to load, and that defines a few arguments to pass to the boot process. And the other thing it uses, it is this raw ignition. I mean, this is something that's not so used in the Matchbox provider. Normally, the more usual way is to use it through templates, but we use it through this raw ignition because we are going to create that ignition file through the Terraform provider. And that ignition file basically defines how the different sections that the ignition config has: the networkd, the users, the system, The idea is that we want it to be reusable, so those are modules again. And why why again the indirection? For this example, I really don't need it, but I wanted to provide a complete example that showcases that you can create modules with your ignition config that can be reusable for different groups or groups of servers that you are installing. What's the look of that ignition? So, for example, this systemd unit, you create, for example, that member service that we are going to, at the end of the day, you need something like a file that contains variables or a systemd unit or whatever. So the best idea of doing it in Terraform is through a template, and then basically you use that ignition systemd unit that renders the JSON, and that JSON is appended to the whole ignition file that we defined in the other in the other module. Again, this is all there, so I don't want to go through a lot of details, but so that you have an idea. What else do we have here? So we had Matchbox, and we have DNS mask, and what kind of things we have in DNS mask. So things like which is going to be the booting process, and a few host reservations for the DHCP part. What kind of things do you have here? What this gives you? Things like, sorry, better this way. This is going to chain load to another iPXE call that in which you specify, hey, give me all that I need in order to use properly selectors. Okay. One difference here from what I told you is that we are going to be using iPXE directly, because to set up PXE with VirtualBox proved to be a pain in the ass. And it was much easier to use a CD-ROM image that iPXE provides and go directly the iPXE route. So the idea is that here in these servers that I'm going to be running, those load this iPXE.iso image that iPXE provides. So it's easier, more convenient, and I'm lazy, as every DevOps have to be. So what else? Okay, now what I need to do is to create the Terraform configuration. So we are in the environment. Here, there's nothing. Okay, so what I'm going to do is to create a plan. What this is going to do is to load all that render configuration into the Matchbox server, and then we apply the plan. And this has created a few files. For example, this master one that is very similar to what I told you. Those profiles, one for each. This shouldn't be needed, and you should be able to create one profile for all of them. The problem is that the moment that you delete the profile, even if you haven't deleted everything. So I prefer to create one profile for each, because it's free. And it creates those ignition files, basically, that have all the configuration that you need, and they're going to create also a user to boot. So we have everything that we need. And let's see what happens. These are my tests to make sure that it works. And let's boot one. So what it is going to do is to download all those files, and let's see what happened in the logs. Basically, they get that boot iPXE, which was set by DNS mask. This chain load to another iPXE call with all the all the selectors that we are going to be using, and then we matched an iPXE config. We deliver the assets. We deliver the kernel and the init ramfs file. Then we deliver, once the boot process continues, you remember that we had an argument that says, hey, the config, get it from this URL, and it is delivered. So let's do the same with the other two servers so that we can have a real cluster. Let's wait for them. Okay, they're here. Okay, so let's log in one of the servers. Okay, and this should report a healthy cluster. Fingers crossed. Okay, there's for some reason one of the servers is not up and running, but the other two are. I will take a look at this. Okay, master 3 is not reachable. The demo effect. So it's there. Why it is not reachable? Okay, it was just a matter of time. It was negotiating. So that's it. This is our way to, for example, install a Kubernetes cluster in our cluster, our Baremetal cluster. There are cool solutions from CoreOS like Tectonic, but they are paid solution, or they are limited in the number of servers that you can use. So we went the heroic way, as I love the term from the Mesos talk. We went the heroic way, and we installed everything by ourselves, and that's it. So if you have any questions, happy to answer.